First, I will talk about object detection. This is a separated package I've added to the sign detection step. It calls road sign detector. Here we have the three signs: stop, turn right, turn left. Those are weighted files that I downloaded from the web. And I'm using a hard cascade classifier, which was very cost effective and fit this task very good in my opinion. The last thing we have here is the addition of a bounding box for the classified class on each frame. This is the main function for this step, the sign detection. Here I'm adding the timestamp just for me to know what is the frame per second rate. And this is the image resolution that I chose. It was a good trade-off between the resolution and the running time. It worked good for me. And here on each frame I'm adding the bounding box and specifying what sign it was, and recording the video, which is recorded directly on the Pi, and you will watch it yourself right now. Those are the road signs the detector should detect. And you can also see the frame per second, which is 4.5. Here, some of the signs are similar, but not exactly the same, and it's good that they weren't detected. Before I'll show you the main function for the advanced mapping step, I want to discuss a separated package I wrote, which called mapping. This package relates to the mapping process that it also uses in later steps. Here we have four classes. The first one, scanning grid, constructing a grid including all the required inner parameters that relates to the grid. Map coordinate holds the location in a real world in 2D and calculates the heading angle in degrees the car needs to turn for its next move. Maneuver specify the ground that need to cover for this current move in the direction of a certain heading. And we have the class mapper, which is the most complicated class of the four, and its main two functionalities, well, the first one is updating the grid on each step, and I want to mention here three things. The first one, that here we have the dilation operation. It is an OpenCV very efficient function which I used for the interpolating of the grid. And the blurring, which is also a OpenCV function which I used for clearance, and it mainly is suggesting the A-star algorithm to not stepping too close to an obstacle. Lastly, I've added a memory factor, and this is for the car to remember if it turns so that the sensor cannot get reading of an obstacle. So, but the obstacle is still nearby, so it should return that, remember that it's still existing. The other functionality that is very important here is the navigation plan, and here we have the call to the A-star algorithm, which updating the path on each step. Here is the main function for the advanced mapping part. And I just want to mention here that this constant, it's because I've decided to reduce noise by reading the distance several times, and then I'm checking if the distance stayed within the same range, and if its standard deviation is too high, I'm assuming it's noise. And now I'm going to show you a result of this function. In the left, you can see the sonar located at the origin, and I marked the actual reference points to the image. The mapping results are aligned with that, as you can see in the right. Here we have the main function for the self-driving navigation step. This function uses the mapping package which I've described earlier, and its inner functionalities are implemented inside this package. The main thing I'm doing here is defining the init position of the car, which I've decided to be 0, and the two destinations the car will drive to. First to destination A, then to destination B, and in the demo I will show you soon, can see those destinations marked on the floor. Each time the car is heading towards a specific destination, and while doing so, on each move it might use a maneuver if the heading need to be changed, or just continue forward. Another thing I want to mention is that I found the right balance between updating the grid and the moves of the car, and what worked best for my algorithm was updating the grid on each fourth move. And now you're going to see the result of this algorithm. You can see the origin and destinations marked on the floor. In addition, you might see a slight shift between the calculated destination and the actual one due to dead reckoning extrapolation. To the left, you can see the visual output of the A-star navigation algorithm. The full self-driving step is mainly an integration of all the previous steps I've mentioned before. I'm using here both the mapping package and the road sign detector package, and the code itself is very similar to the code in self-driving navigation file, only that here I'm also adding the object detection part. The pi is recording the movie from the frame it sees, and I'm calling the function stop on sign. I've decided to integrate the symbol of stop, and once a stop sign is recognized, the pi car is halting until it doesn't see it anymore. The reason I'm doing it is for you to know that the pi is actually reacting to the symbol and not just halting by chance. And now to the final and very exciting demo right ahead.